Hello everyone. In this lecture we will discuss artificial variable technique and the method is two-phase method. Here I will discuss one example with no feasible solution. So let us start this example. Here we have to minimize it, which is x1 minus 2x2 minus 3x3, and these are the constraints. So first we convert this problem into a standard form. So for this you can assume let z dash equal to minus z, so you can write it maximize z dash this equal to minus x1 plus 2x2 plus 3x3, and look at the constraints. Equal signs are there. Do we need to add artificial variables? So suppose just try to find initial basic feasible solution without adding artificial variable. What will happen? See, number of equations 2, number of variables 3. It means one variable is extra. So if you assume x1 equal to 0, so you will get value of x2 and x3. So can we take this solution as initial basic solution, or these two variables x2 and x3 as basic variables? Now look at this. The matrix corresponding to x2 and x3. This is 1, 3 and 3, 4. It is not a unit matrix. It means we cannot consider these as basic variables and this solution as initial basic feasible solution. That's why we need to add artificial variables. Here you cannot add slack or surplus variables because these two are equal signs, not greater than equal to or less than equal to. So you can write on adding artificial variables a1 and a2. So these equations will be 2 minus 2x1 plus x2 plus 3x3 plus a1 equal to 2, 2x1 plus 3x2 plus 4x3 plus a2 equal to 1. Now look at this number of equations 2, number of variables 5. So it means 3 variables are extra. So you can assume x1 equal to 0, x2 equal to 0, x3 equal to 0. So you will get a1 equal to 2, a2 equal to 1. So now look at this. If you write the matrix corresponding to these equations, the part of the matrix corresponding to a1 and a2, this will be 1, 0 and 0, 1. So which is a unit matrix. So you can consider this as a initial basic feasible solution. So these two variables are basic variables and these variables are non-basic variables. So there is an initial work which we do with every problem. Now come to the two-phase method. So phase 1. Remember the objective of the phase 1. The objective of the phase 1 is to find the initial basic feasible solution, because here there is not initial basic feasible in the term of original problem, because here artificial variables are there. So the objective of phase 1 is to find the initial basic feasible solution for this problem, and for this we consider a new function. You can write it z dash, or say another symbol z dash star. This equal to, here you will write only the artificial variable with negative sign minus a1 and minus a2. So this is the objective function for first phase, and the purpose of this is to find the initial basic feasible solution for this original problem. Constraints are these two equations. Non-negative restriction, if you wish to write, is x1, x2, x3, a1, a2 greater than equal to 0. So there is a new problem. Objective function is this one, constraints are this one, and there is a non-negative restriction. So using this problem, we will write for simplex state. Here the basic variables are a1 and a2, their coefficients. Look at this in the objective function, minus 1 and minus 1 and minus 1. Here x1, x2, x3, all these are absent from this one. So coefficients are 0, 0, 0. This is minus 1, this is minus 1. xb is a value of basic variable, so this is 2 and 1, the value 2 and 1. Now these are the coefficients of x1 x2 and this, so here you will write minus 2 2, this is minus 2 2, 1 3 3 4 1 0 0 and 1. So now we will find the value of z. So if you find z, this is minus 2 minus 1, so you can write z dash star this equal to minus 2 plus minus 1, this is minus 3. Now delta 1, here it is delta 1. This delta 1, how we calculate? This we calculate cbxb minus cj, cbx minus cj. So dot product of cb and xb minus cj. So minus 1 minus 2, so this is plus 2 minus 2, so this will become 0. So this is 0. Now look at this, minus 1 minus 3, so this is minus 4 minus 4 minus 3 minus 4 is minus 7. All these are because 0, so simply we have to calculate the dot product of these two. So minus 7, this is minus 1 minus minus 1, it means this is 0 and similarly this is 0. Now look at this, some values are negative, it means it is not an optimal solution. So we have to find the most negative. So x3 is the variable which will enter into the basic solution. So now to decide the outgoing variable, we will find the ratio of xb and x3 is the incoming variable, incoming vector. So all these are positive, so you can write the ratio 2 by 3, this is 2 by 3 and 1 by, this is 1 by 4. So this is minimum, so this is the outgoing variable a2. Now a2 will be replaced by x3. So how can we proceed? So move to another slide. I have written all these values. Look at this, a2 is, this is outgoing, this is incoming. Now we have to make it 1 and this as 0 because this will replace a2, so it should be 0 and 1. So we'll write another table. Here I have written values. How can we write these values? I have already calculated. So what will be the rules for this one? Now look at this, suppose you write it r1 and suppose it is r2. So what will the rule for r2? You have to make it 1, so r2, this is r2 by 4 divided by 4, so you will get the rule for r2. Now for r1, now look at this, you have to make it 3 because it is 3, you have to make it 0 with the help of this one. It means we have to make it 3, so first divide it by 4 then multiply it by 3. So you can write it r1 minus 3 r2 by 4. 3 r2 by 4 divide by 4 means it will become 1, multiply by 3 means it will become 3. Then you subtract it from this one, then in this way this will become 0. So these are the rules for r1 and r2. So for new rows r1 and r2 with the help of old rows. Okay, now look at this, here the basic variable is a1, its coefficient is minus, this is fixed. The a2 is replaced by x3, its coefficient is 0, so it is 0. So these values are fixed. From here onwards, from this point to this point, these values are calculated with the help of these two rules. So here I have calculated, you can check and verify all these values. Now look at this, here z dash star, this is minus 5 by 4 and delta 1, delta 2, delta 3, all these values are greater than equal to 0. It means this is an optimal solution. So can we consider this as the initial basic feasible solution or not? Now look at this, in this solution artificial variable is there. Artificial variable means simply of no use. It should not be there to be considered as initial basic feasible solution. Since this artificial variable is there with a positive value, it means it signifies that the original problem has no feasible solution because one artificial variable is there. So here you have to check whether artificial variable present in this optimal solution with a positive value. If it's so, just like as in this example, simply you will write no feasible solution. No feasible solution. It means you need not to go to phase 2 because we are not getting any feasible solution. And I will stop the problem here, simply writing no feasible solution. And the reasoning behind this is, since one artificial variable is there with a positive value in this optimal solution, that's why the problem has no feasible solution, because the artificial variable should not be a part of this optimal solution. Artificial variable is added just to solve the problem, just to find the initial feasible solution, because it has no other use. So this problem has no feasible solution. So I hope that you got the concept of no feasible solution while utilizing two-phase method. Thank you.